All right, welcome everyone. We're going to go ahead and get started here tonight. We're going to go over our project on probability. But before we do that, just a couple of things I want to talk about. I want to just touch on a few things in the lesson before we talk specifically about the project so that you have an idea of how these two relate to each other. So, obviously, of the most important here are our objectives tonight. Okay. Being able to distinguish between probabilities based on random and independent events, and then being able to translate that into a use of Punnett squares to calculate the probability of genotypes that you will see in terms of genetic inheritance. Okay. Last week you did the project on Punnett squares. Now we're going to take that one step farther and we're going to look at it from a statistical analysis standpoint. So that way, when you put everything together after this genetics unit, you have a good understanding about how to statistically look at how traits are passed down from one generation to the next. Okay, so a couple of points to remember that when you're talking probability, you're talking about mathematics in terms of dealing with the issue of chance that certain events will occur. Okay, so probability is really that tool that helps you determine the elements of chance. Okay, or how randomly occurring events do in fact happen. So, talking with that, let's roll over and talk a few minutes about the project. Okay, so in the project, you're going to be looking at experimental probabilities, and you don't really need a lot. Okay, it says two coins in a cardboard shoebox, and really you don't, the shoebox is even optional. You don't even need that. Really, all you need is two coins. Okay, and it doesn't matter what they are: the pennies, nickels, dimes, quarters, whatever. Okay, so what you're doing here is you're actually going to be looking at some statistical analysis for tossing a coin in the air. And before we do that, remember what your lesson talks about is when you're talking about probability, you're talking about the randomness of events actually occurring. So when we talk about throwing a coin in the air, we're talking about every time we throw a coin into the air, we're talking about an independent random event. Okay, meaning the coin has a 1 in 2 chance or a 50% chance of landing on heads or landing on tails. Okay, and that's really one of the most important pieces to remember for the project. Okay, so your project discusses the procedure. So what you're going to do for this is you're going to be tossing whatever coin that is, if it's a penny, fine, up into the air, and you're going to be recording. So you're going to need some kind of piece of paper to record whether it comes up heads or tails. Okay. It says flip the penny in a shoebox to prevent it from rolling away. It doesn't matter. You can do it on a table, you can do it on a counter, you can do it on a floor. You can really do it on whatever you want. I mean, the shoebox, that's great if you have it. If you don't, it's not a big deal. Okay. And you're going to discuss here whether or not what are the chances for tossing heads or and tossing tails. And we just discussed that from the perspective of what are the chances? Well, you have one coin and you have a head side and you have a tail side. So probability being the chance that a random event will happen independently, that's essentially what you're going to be recording for that answer. Secondly, okay, and number two, you're going to toss that coin 10 times and record the number of times that it comes up heads and number of times that it comes up tails. Okay, now with that, all right, you're going to make some predictions. Okay, A and B in here ask you how many times would you expect to get heads and how many times you would expect to get tails. Okay, now in order to do that, remember the expectation is that if you have a 50%, a 1 in 2 chance every time you throw that up there to get heads or tails. So if you did that 10 times, okay, essentially what that's saying is that half the time you would expect to get heads and half the time you would expect to get tails. So if you have 10 instances, those numbers should be 5 and 5. If you did it 100 times, you would expect to get 50 and 50. If you did it 200 times, you'd expect to get 100 and 100. Okay, so those are the expected experimental results. Now, this is what I've been getting a lot of questions on here. Calculate and record the deviation observed from what you expect using the following formula. So in order to figure out the deviation, which is in most instances a decimal number, you're going to take the difference between the expected heads that you would expect to get and what you actually got, and add that to the difference between the expected tails and the observed tails that you got, and divide that by the total number of tosses. So what does that mean? Okay, so let's use an example here. For example, if up here in part 2, okay, you recorded that you expected to get heads 5 times, but in reality you only got heads 4 times, you would figure out the difference between that, okay? And you would add that to the difference that you got between the number of tails that you threw. So for example, if in that instance you got six observed tails, but you expected 5, that would be what you would put on this side of the equation. So you would add those two numbers up. So the difference between the observed and the expected. Okay. So here we talked about an instance of you observed 4, but you expected 5. Okay. So the result here would be -1 plus 1. Okay, and then you would divide that by the total number of tosses, which in this instance would be 10. Okay, and you would get a value. Now, what does that value mean? That value means, and it explains it down here, the more experimental results deviate from the expected results, the more the deviation value will approach the value of 1. Now, as your results get closer to the expected results, the deviation is smaller and nears a value of 0, okay? And some of you might have values like 0.2, some of you might have values like 0.8. Believe it or not, and there are instances where some of you will get values of 1, okay? And that's okay. You should never have a value over 1, though, okay? Just like you should never have a value under 0. You should never have a negative value, okay? So you're going to have a value somewhere in between 0 and 1, and that's okay, and it's a decimal, okay? Now, from there, you're going to continue tossing the coin, okay? And you're going to continue tossing the coin and record your results until you've tossed the coin 100 times. Yeah, I know that's a lot of tosses. But the goal is then we want to see what the deviation is after 100 instances. If in fact probability is working out, what you will start to see, okay, as you get closer to the expected results, you're going to see that deviation number come closer to 0. All right, or you should in some instances. Not all of you will. That's okay. Okay, and then you're going to repeat the 100 toss trial again, and you're going to record the total number of heads and the total number of tails that you've attained from all those, and then you're going to actually determine what the deviation is for 200 tosses. Okay, and then finally you're going to obtain 2 pennies or 2 coins, it doesn't matter, and you're going to toss both coins 100 times, record your results, okay, and answer the following questions. From there, it asks the percentage of occurrence is the obtained results divided by the total tosses and multiplying by 100. Okay, so what you're going to do is you're going to get the results that you obtained by tossing the pennies, okay, the 2 coins. How many times did you record heads? How many times did you record tails? Okay, then from there, you're going to divide by the total number of tosses. Okay, the total number of tosses for this instance is 100. You're going to divide whatever number you get from those by 100 and then multiply it by 100, and that should give you a percentage. Okay, a percentage of the occurrence of getting of two heads on the coins, and the percentage of getting tails on both of those coins. Okay, um, and then it's going to ask you what is the percentage of occurrence for one head and one tail. Okay, again, how you do that is based upon you separating the numbers for each result that you get. Okay, so for A and B, you're looking at the instances that occur for both coins, and then for part C, you're only looking at the instance as if they were each only one coin. Okay, so for example, sometimes we see numbers like up here we see like 19 or 20%. Down here we see like 20 or 30%, and then part C sometimes we see numbers 50, 60%. Okay, those are just some examples to kind of guide you to see what we technically get over the course of a whole group of students if I were to look at all the data. Okay. Um, After you do that, you can copy and you can paste your answers into here. You can copy or paste them into a Word document, or if you're really cool and snappy, you can do it on a spreadsheet. Okay, and send it to me via spreadsheet, because that's really cool too, to look at those numbers and then analyze that. What I like to do is I like to get all the numbers that the kids get in the class, and I like to actually throw them all into Excel and create a big document and see how close we actually got to true percentages. Okay. Um, so if you want to do that, that's cool. If you don't want to do that, that's cool as well. It doesn't matter to me, just as long as you do it. If you have problems with this assignment, certainly come back into the VO and we can talk a little bit more about it and break it down. If not, good luck, and we'll be back here next week talking about another topic for the class. Have a great week, everybody.